50 years ago, humanity entered a new era when two heroic explorers took a small step into a new world. It was a massive technological breakthrough. Aside from the achievement itself, it spurred innovation in medicine and agriculture and business and consumer products. And in a strange way, it brought us all a little closer together. I'm talking, of course, about spreadsheets. 1969 was the year that Remy Landau and René Pardo founded Lampar Technologies. As well as being a play on their names, Lampar stands for the language for programming arrays at random, which contain many of the features that we associate with modern spreadsheets, most notably forward referencing, or as we call it today, reactive programming. Now, you've all seen forward referencing in action, but you might not have been aware of it, so allow me a demo. This is a spreadsheet where I track my personal fruit consumption habits. In columns A, B, and C, we have some straightforward values, but in column D, we have something more interesting. We have formulas. The values in column D are derived from the values of column C, which means that when I buy another cantaloupe, the subtotal and the subtotal update themselves automatically without any further intervention. Behind the scenes, the way this works is the spreadsheet maintains a thing called a dependency graph, which we can visualize. Each of these cells has an input and an output, and we can click around and see what shape that dependency graph is. And as we change the spreadsheet by adding new formulas, it adds new inputs and outputs to these cells. Now, that was pretty important back in 1969 because compute cycles were at a premium. And so it is important to be able to update things as efficiently as possible. But Lampar was never destined to become a household name. It was too far ahead of its time. Instead, nowadays, when we think about the first electronic spreadsheets, we think of VisiCalc. VisiCalc was a huge deal back in the 1970s. Steve Jobs credited the success of the Apple IIe, pictured here, with VisiCalc. But VisiCalc didn't implement forward referencing. Instead, whenever you changed a value, you would have to refresh the entire spreadsheet. It would go cell by cell, recalculating every little piece of the spreadsheet. And a few years later, when Lotus 1-2-3 came out, and it did use forward referencing, spreadsheets were suddenly much more powerful. They could be used for many more things. And as a result, VisiCalc was soon all but forgotten. My name's Rich Harris. I'm a graphics editor at the New York Times. And this talk is called Rethinking Reactivity. It's a talk about how we can apply the lessons of our forebears to build apps that are a little bit less VisiCalc and a bit more Lotus 1-2-3. Now, reactive programming, as we've seen, is all about tracing values through a dependency graph. We can't talk about reactive programming without talking about React. Who here has used React? I know not everyone here is a front-ender, but raise your hands anyway. OK, so React is pretty incredible. React has changed how we build web applications for the better. And since it came out in 2013, the React team has crushed it year after year, helping us solve problems that we didn't even know that we had. But I'm standing here today because I think we can do better, quite a lot better, in fact, and I'm going to talk about how. Before I begin, I need to explain that I know that we get a little bit squeamish about criticizing each other's work in public like this, but I think it's essential for our collective growth to question the assumptions that our technologies are based on. And if you look back to the early days of React advocacy, people did exactly the same thing, comparing it with Angular and Ember and the frameworks that were in vogue back then. So I'm continuing in that proud tradition. React was the first virtual DOM library. Some of you may have seen code like this before and know how it works, but I'm going to show you it anyway. This is a very simple React app that has a single component, app. At the beginning here, we have some local state, count, and some local state called name, and we have a couple of event handlers. Handle click calls setCount, which changes the count value. Handle input changes the value of name. And then at the bottom, we turn these values into some virtual DOM that then gets turned into what the user actually sees. And it looks a little bit like this. If we change stuff, it reruns that, generates a new virtual DOM, and figures out what changed. So let's look at how that works. We take the old one and the new one, and we need to compare them to figure out what's changed. We start at the top level element. It's a div. It's still a div, so we keep it. Then we look at the attributes. It had a class name, app. It still has a class name, app, so we keep it. Then we look at its children. It has an H1 element. It's still an H1, so we keep it. It has some text, hello shift, hasn't changed, so we keep it. Then it has an input. Its value hasn't changed, so we keep it. It has a button. It's still a button. We keep it. It has some text, which has changed from clicks 4 to clicks 5. All that work to change a 4 to a 5. As engineers, we should be offended at all that waste. But that's not even the worst part. The worst part is that we're rerunning this code on the left every time there's any state change in our application, we're regenerating both of these functions, even though we know just from looking at the code that at least one of them is never, ever going to run. The reason that this is built this way is that React doesn't have any awareness of the values flowing through your application. It treats your code as a black box. In other words, by any reasonable definition of the word, React is not reactive. So is the virtual DOM fast? Well, no, not really. Is the virtual DOM fast enough? That's a bit more of an interesting question. I work with data visualization and animation and heavy interactivity, and I would say that categorically, no, it is not. But you don't have to take my word for it. We can ask the React core team. They don't think the virtual DOM is fast enough either. We know this because they've given us things like should component update, React pure component, use memo, use callback. These are essentially abstraction leaks that allow you, the developer, to say, don't worry about updating this subtree, I know what's going on. In other words, you're doing the computer's job. Another symptom that the virtual DOM isn't fast enough is we're seeing the development of what I call amortization strategies, like time slicing, which we'll talk about later. Now, this is a bit of a problem, right? Because I want my users to have a fast experience using the things that I build, but I want to build them using a nice declarative component framework. And a few years ago, it occurred to me that maybe we're thinking about the problem all wrong. Maybe our understanding of what a framework is all wrong. You see, frameworks are not tools for organizing your code. They are tools for organizing your mind. So given that, what if the framework isn't a thing that runs in the browser at all? What if it runs in your build step? What if it became a compiler? And that's what Svelte is. It's a compiler that turns your declarative component code on the left into the equivalent imperative vanilla JavaScript code on the right, the kind of code that browsers are very good at executing. The interesting part here is this value changed. How do we figure out what changed? Now, the conventional answer to this problem, how do we tell the computer that something changed, is to call a function. This is how it is in React and many other frameworks. When we call setCount, that is the indication that some state has changed. But take a step back for a minute. How do we tell the computer something changed? When we're not thinking about user interface frameworks or any of that stuff, the answer is pretty straightforward. We use the operator. Specifically, we use the assignment operator. We would say let count equals 0, count equals count plus 1, or more concisely, count plus equals 1. Now, to give credit where it's due, Vue figured this out years ago. The Vue model has this.count plus equals 1, and this is a proxy or an object with accesses that triggers the change detection mechanism and causes an update. The addition of this has some ramifications that are quite hard and counterintuitive to understand at first, so we decided to get rid of that. But Vue can't because all that stuff happens in the browser, and they're constrained by the rules of JavaScript. We're a compiler, so we're not constrained by the same rules. In other words, Svelte moves reactivity out of the component API and into the language. And here's what that looks like. This is the same application that we had before implemented in Svelte. Just as before, we have some local state name, and we have some local state count. And we have the same functions that we had before, except this time, we're just doing count plus equals 1 and name equals event target value. And if I interact with the application, the state changes as you would expect. How does this work? Well, we can look at the JavaScript output that the compiler generates and see for ourselves. Down here, we can see the code that is actually running. And it's basically the same code that we wrote, except that the assignments here, count plus equals 1, have been wrapped with this call to invalidate, which is a function that says to the component, hey, this value has changed, and I'm going to schedule an update for the end of the event loop. And when that update happens, this is all the code that's involved. If change.name, well, we can ignore that if we've been clicking the button and changing the count, so we just run this function, which tells the text node that its new data is whatever the current value of count is. And this is breathtakingly efficient compared to the traditional framework mechanisms that we use. We can actually get a little bit more efficient here. We don't need to use event listeners. Because we have a template system, we can use a binding. Let's get rid of that, get rid of the event handler. And of course, we can use inline event handlers as well. So count plus equals 1, get rid of that. And so we can have components expressed with very limited code. Now, because we're writing JavaScript in our HTML instead of writing HTML in our JavaScript, we have a little bit more flexibility about the code that gets generated. For example, we could toggle it into server-side rendering mode, and then it'll just generate a string. It'll concatenate a string, and then you can serve that to someone who's hitting your server. And that is orders of magnitude faster than generating a component tree and serializing it. In other words, if you use Svelte for your server-side rendering, your AWS bills will be lower. Tell your bosses you could save them some money. And this is what it looks like to use. You import it like any other JavaScript module, import app from app.svelte. But we're not reactive yet, because most of the time when you're building components, you will have some state that is derived from other state, just like we had in our spreadsheet. And the way that we would do something like this in React is, well, we don't need to because the code runs all the time. This is a simple to-do list. The to-dos are defined at the top. And then down here, when I click these, we toggle the done state of them. And down here, we can generate a filtered view of that list that includes the ones that, all of them, or only the ones that haven't yet been done. And this will just get rerun every time there's a state change. That's not ideal because we might be regenerating that filtered value even when nothing has actually changed if this component is inside another larger part of your application. So in React, what you tend to do is use this useMemo function where we pass in the arguments that that expression depends on. And then when it reruns, it will compare those values with the previous run. And if they haven't changed, it knows the return value hasn't changed. And so it just gives you what it's already calculated. But that's more work for us. We've had to write that extra boilerplate. Just zoom out a little bit so you can see the whole thing. This is the equivalent application implemented in Svelte. And it's a lot less code, first of all. That's not unusual. This is something that we see time and again. I've converted a lot of components between different frameworks. And typically what you find is the React component has about 40% more characters. That's 40% more stuff that you have to type, 40% more surface area for bugs, and so on. The other thing you'll notice, though, is that this doesn't actually work. If I click these things, nothing is toggling, and nothing changes when I toggle the hide done. And that's because down here, we have a const. And because this code only runs once, it can never change. It's a const. We need some way of saying to Svelte, this value is reactive, just like our local state is. And for that, we need to look elsewhere for inspiration. Who here is familiar with observablehq.com? Not so many people. Well, this is a hugely popular tool in the data visualization world. It's built by the creator of D3. And it's an interactive notebook similar to runkit.com or Jupyter in the Python world, but with one key difference. Instead of running your code sequentially the way that we normally expect it to run, it runs your code in topological order, which is a fancy way of saying that it computes a dependency graph from your statements, and if statement A depends on statement B will run first, even though they're in a different order. In other words, it functions like a spreadsheet. Well, we like spreadsheets, so maybe we can use that. A blog post I like by a chap named Paul Stabell, What is Reactive Programming?, tells the story of some code anthropologists from the year 2051 trying to make sense of the code that we wrote today. var A equals 10, var B equals A plus 1, A equals 11, B equals A plus 1. We need to reassert that B is equivalent to A plus 1. This is confusing to these historians from the future because in the future we have something called the destiny operator. Var A equals 10, var B destiny A plus 1, A equals 20, B has already changed as if by magic. They are bound. It's explicit, a part of the language. Could we implement the destiny operator in JavaScript? Well, no, because it wouldn't be syntactically valid, but it turns out there is a piece of syntax that we can use. Is anyone familiar with this? This is what's called a labeled statement. The label is used with for loops and while loops, but the rest of the time it's just sitting around doing nothing. So we on the Svelte team have repurposed it. We've claimed it as our own. This is our destiny operator. Let A equals 10, $B equals A plus 1. The values are now bound. So if you apply that to our to-do application, find our const filtered down here, and change it to $filtered, this is now reactive. And we can go a little bit further. Showing equals filtered.length. And then now we can include that in our user interface. Now when we toggle these, It updates both of those things automatically. And we're not limited to declarations. We can also have side effects. And that's really useful for debugging values as they flow through your application. How does this work? Well, we can take a look at the output. Svelte has generated this update function here. And you can see that it's checking the values have changed to see what it needs to recalculate. It knows that console.log showing can't run until we've recalculated showing, and it knows that showing can't be recalculated until filtered has been recalculated. So it switches the order around. That's the topological order that we were talking about before. And this code, of course, is very fast for the browser to run. It's very limited. There's no dependency tracking that happens at runtime. Now, a lot of people on first seeing this think, I'm not sure about that. That looks a little bit like magic. And in our world, magic is rarely a compliment. We're changing the semantics of JavaScript, and that seems bad. But actually, changing the semantics of JavaScript is kind of what frameworks do. It's their whole thing. In React, we change the semantics of function calls. Hooks behave differently to regular functions. In Vue, we change the semantics of a property assignment. In Angular, we change the semantics of events and timers. It literally monkey patches add event listener and set timeout and various other things. That's how the change detection works. The only difference is we're doing it at compile time, which is more efficient. Something that I like to do is when someone tweets out a benchmark showing how fast their framework is, I will add Svelte to the framework and tweet it back out again. And if you're thinking, Rich, you need to get out more. You're right, but look at this. It's worth it. This is a benchmark, quite an old one, showing that Svelte is roughly 35 times faster than React and 50 times faster than Vue at this specific test. But some people think that's not very useful. Dan on the React core team says that this is a meaningless benchmark showing that you can do hundreds of thousands of updates a second. There's no point if your refresh rate is 60 hertz. Although, side note, your refresh rate isn't going to be 60 hertz for long. VR devices have refresh rates of 90 hertz or 120 hertz. So if you thought your frame budget was tight now, it's about to get a lot tighter. So the React team has been thinking about what the real purpose of all this is. It's to improve user experience. And their answer is to introduce something called concurrent mode, which is coming to React later this year. And the best way to explain what concurrent mode is to use one of Dan's own demos from a talk that he gave in Iceland last year. And if you haven't seen this talk already and you work with this stuff, then I really do recommend that you watch it. It's a very important and insightful talk. So this is what React is like today. When I type, the browser starts to lock up. And that's not a great user experience. The way that people have sometimes tried to solve this is with debouncing. Now, when I type, nothing happens until I stop. But that's not great either, because we don't get any feedback about what we're doing. The app still feels broken. So with a new feature called time slicing, we get the best of both worlds. When I type, React updates as fast as it can, but yields. It yields the main thread so that any pending updates can take precedence, and it will abandon any work that it's already begun. And this is clearly a much better user experience, although you'll notice that it's still a little bit choppy. So this is the same application implemented using Svelte, and you'll notice that when I type, the browser just keeps up. Oops, I can't type. With no problems. Right? This is clearly a much better user experience. Instead of unblocking the main thread, we're just not blocking it in the first place. Now, the last time I gave this demo, it got a little bit misunderstood, so let me be clear about what I'm saying. I am not saying that concurrent mode is obsolete or bad or anything like that. It's actually very exciting. It's a really great time to be a React developer, and I look forward to stealing the best parts of this work and incorporating it into Svelte. But I've heard a lot of people say that we don't need to worry about performance in React apps because concurrent mode is going to save us. And unfortunately, that's just not true. Time slicing cannot make your app run faster. It can only spread out the work. It can't make your animations run at 60 frames per second if they don't already run at 60 frames per second. So, there are a few different ways that people try to speed up their code. And as we've just seen, breaking it into small chunks and moving it around doesn't really solve the problem. Putting it in a web worker. This was very fashionable a few years ago. Everyone was trying to do their work off the main thread by putting it in a web worker, but it turns out that you don't gain anything. The overhead of transferring between threads just wipes out the gains for most user interface tasks. The current thing is to try rewriting everything in Rust, and it turns out that for UI, that doesn't really work either, although Rust is very good for more computationally intensive tasks. Turns out the only way that you can reliably speed up code is to get rid of it. You have to be like Marie Kondo. Does this JavaScript spark joy? I don't know if Marie Kondo is a thing in Croatia. I'm sorry if that made no sense. Now, when people like me harp on about performance, we're often told that we have our heads in the clouds and we're not concerned with the real-world issues that developers face. And I find this maddening. It's incomprehensible because performance is the most real-world thing there is. Stone is a company in Brazil that builds point-of-sale systems that you put your credit card into. And they tried building the apps for these devices using all of the different frameworks, React, Vue, and so on. And they couldn't get the results that they wanted. They tried Svelte, and everything worked beautifully. Simple things like click feedback were horrible over half a second with other frameworks. So now, in the real world, on the streets of Brazil, there were 200,000 point-of-sale systems running Svelte. MustLab in Russia is another company that gets it. They use Svelte to build applications for smart TVs. These are all pretty low-power devices, and this is a trend that is only going to increase. The mobile web is not the new frontier anymore. The new frontier is the embedded web, wearables, Internet of Things, in-car entertainment systems, smart home control panels, all of these things that have displays, they need interfaces, and a lot of the time, those interfaces will be built on the web. And our traditional JavaScript-first frameworks simply aren't going to cut the mustard. But that's enough talk about performance. I want to talk about how Svelte can help you build better applications as well as faster ones. First up, accessibility. This is something that we all care about in theory, but collectively we tend to do a pretty bad job of it, and it's understandable why. Most people who work in development, we don't have visual impairments, we don't have problems with motor skills, and all of the things that make browsing the web very difficult for a large portion of the population. So Svelte, as a tool, is well placed to try and help you fix this. It will warn you if you're creating markup that is inaccessible. For example, here we have an image that doesn't have an alt tag, which means that if you're on a bad network and you can't download the image, or if you're using a screen reader because of a visual impairment, you wouldn't know what's in that image. So we add an alt tag equals shift logo, and the warning goes away. Now, it's just a warning. It won't fail the build. It will allow you to write inaccessible code, but it won't respect you for it. Another thing that we can do, we can generate scoped styles. So we've all experienced that thing where you're writing your CSS and everything starts clashing with everything else, and you don't want to delete any of it because you don't know what's going to be affected. Well, in Svelte, because we're writing into a superset of HTML, we can just put our styles directly inside our components, and they get scoped. This nested component here, if we click over to that tab, we can see that it also has a paragraph element, but it's unaffected by the styles in the parent. And we can add some more styles here. Text transform uppercase. And it will only apply to this component, not to the parent component. The way that this works is it adds a computer-generated class that is guaranteed not to clash with anything else on the page. Another useful thing that we can do when we control both the markup and the styles is we can see which styles aren't needed. And it's giving us this warning. You have an unused CSS selector, and it's not including that CSS in the output. So this frees you from the worry of whether or not you can delete CSS. Another thing that I think is really important when you're building a user interface is to have transitions between different states. Here we have a visible Boolean, which is connected to this input. When I toggle that, the element just flies in and out because we have this transition fly directive on the element. Now, interestingly, this is all being done with CSS. It's not being done with JavaScript. And that's important because CSS animations happen off the main thread, better for your battery and better for performance, particularly if there is other work going on. And if I toggle this rapidly, it will just interrupt the current transition and return it to its natural state. And we can have custom transitions as well. We can get pretty funky. Here's a thing called a spin transition that I've just added, and it manipulates the transform and the color. all we're doing is returning a function that for any given t value between 0 and 1, 0 is all the way out, 1 is all the way on, it will generate some CSS. Svelte will then turn that into a CSS animation. So if I import spin from spin.js, and then replace all of this code here with in, spin, out, fade, then we can start to have some fun. Just remember that with great power comes great responsibility. And you can take this stuff pretty far. I'm not going to show you all the code for this example, but this is a to-do list with another to-do list side by side. One has the things that have not yet been done, and one has the things that have been done. And if I toggle these, they just go over to the other side. Pretty standard. But that is a bit unsatisfying for our mammalian brains because the real world doesn't behave like that. In the real world, objects move gracefully from one place to another. They don't just vanish and reappear. So I'm going to add some directives to this label here, just like so. And now, when I toggle these, everything moves smoothly from one side to the other. The frame rate on this screen isn't quite perfect, so it's smoother on my machine, but you'll just have to take my word for it. And if we add new things, then they will smoothly animate out of the way. And this is pretty difficult to do with most frameworks. And the reason is that they don't include these features out of the box. The reason for that is that as a community of JavaScript developers, we are obsessed with file size. That means that libraries have to be very careful about which features they add. Because Svelte is a compiler, we don't have that constraint. We can include all of the features. If you're not using them, they just don't get compiled into the output. So we've decoupled feature set from file size, and that means that we can include a lot more stuff. You don't need to go hunting around NPM to find the right package that's going to do the thing that you want to do, check that it has tests, check that it has documentation, check that it works with the current version of your framework. It's all just built in as it should be. So Svelte can do a lot of things, but at the end of the day, it's just a component framework. We need something larger than that if we're going to build real-sized applications. So Sapper is an application framework that is built on top of Svelte that if you're familiar with things like Next and Gatsby, it gives you the same kind of features that they do, but with a lot less JavaScript. Svelte Native is a community-based project that allows you to use Svelte to build applications for iOS and Android. And something that I've been wanting for a long time is SvelteGL, WebGL, but for Svelte. If you've used frameworks like 3JS and Regal, these are really, really cool, but they tend to be a little bit bigger than what you would want if you're trying to build an application with as little JavaScript as possible. And so you tend to not use WebGL as widely as you might. But what if we could build WebGL apps inside our Svelte apps like so? So this is very early. This is not production ready at all. This is just something that I sort of threw together last night. But now we can build 3D scenes in WebGL using the same kind of declarative mindset that we use to build the rest of our web applications. We've got a plane for the floor here, and then we've got a box, and then a plane for the image. And because it's all Svelte, we can mix and match it with HTML, like here, and we can use the rest of Svelte's built-in reactivity to control our WebGL scenes. So I can open a color picker and let's see, change the color of that a little bit, make it green. I can make the width bigger and the height bigger. And hey presto, we have WebGL inside of our regular web apps. And so this is something that is a focus for us at the moment. We're going to be working on that more in the near future. So, in summary, spreadsheets are pretty cool, and we should be more like them. There's one more thing I want to say about spreadsheets, and that is that they are really accessible. My wife is not a programmer, and after being with me for 15 years, she is never going to want to become a programmer. But she can do some pretty incredible things with spreadsheets. And when I look over her shoulder when she's working, I think about how the modern economy is basically powered by spreadsheets. And that's because everyone can use them. And I think, wouldn't it be great if the tools that we use to build the web were as accessible as the tools that we use to create spreadsheets? My friend Eliza agrees with this. She recounts a story of her product manager at Spotify coming over and collaborating with her on some marketing copy without having the whole email, how about we try this phrase, feedback loop, and they could just see it right there and then. And this is when really great things happen. When people from different disciplines can huddle around the same laptop and work on the same piece of code at the same time, that's when we can build the best apps. So I hope that in the future we'll be able to look back and say that in a strange way, Svelte brought us all a little closer together. Thank you for listening.